Okay, in this video, we're going to look at the problems involving first and second derivatives. This is file C from the notes that I've sent. So, first question, find the critical numbers for each of the following functions. Remember, critical numbers are found by looking at when the first derivative is either 0 or undefined. So the first thing we're going to do is we're going to take a derivative. F prime of x is equal to 12x squared plus 4x. Let's factor this, pulling out a common factor of 4x. We're left with 3x plus 1. We want to know when this is equal to 0. And that happens at x equals 0 or x equals negative 1/3. Okay, problem B. Given the f of x is x minus 3 to the 2/5, f prime of x is 2/5, quantity x minus 3 to the negative 3/5. Okay, it's always wise to write your derivatives in terms of positive exponents. So we'll move that x minus 3 to the 3/5 down to the denominator. Okay, we need to take a look at when this derivative is equal to 0. A fraction with 2 in the numerator is never going to be equal to 0, so f prime of x never equals 0. But f prime of x is undefined when x minus 3 to the 3/5 is equal to 0. Okay, when does that happen? That happens when x is equal to 3. So part B has only one critical number. Part A has two critical numbers. Let me just do a different example for part B for just a second, just to refresh your memory about some things. What if g of x was equal to x minus 3 to the 3/5? Its derivative would be 3/5 x minus 3 to the negative 2/5. Okay. And I just want to think about the difference, looking ahead, between g of x and f of x. So I should say g prime of x and f prime of x. If we were going to ask you the question about when is, I'm looking at part B, when is f of x positive, or f prime of x positive, and when is f prime of x negative? Okay. A cubic, right, is sometimes positive and negative. And so this derivative is going to change sign at x equals 3. Okay? And if we test that, if I plug in a value less than 3, like plug in 0, I'm going to have negative 3 cubed. That's going to be negative. Okay? And the fifth root of a negative is a negative. So this function's going to be, this derivative is going to be negative to the left of 3 and positive to the right. So our function would be decreasing to the left and increasing to the right. Whereas with g of x, g prime of x is equal to 0 at 3. But notice this is a squared value. So even if I plug in 0, negative 3 is going to be squared. That's going to become positive. So this function is going to be increasing and then increasing. Okay, so we'll keep thinking about those increasing and decreasing ideas as we go. Okay, question 2. Shown is the graph of the derivative. So this is f prime on the interval from 1 to 6. So I think they probably could have made their graph go a little bit further if they really wanted it to show from 1 to 6. So, it's probably coming down here, Come down here, nice parabola. Okay, it looks like this parabola has zeros at 2 and at 5. All right, it says find the intervals in which f of x is increasing and decreasing. Okay, well, if we have our derivative, we know when our derivative is positive and negative. So remember, when f prime of x is positive, which happens on the interval from 2 to 5, f of x is increasing. Okay, when f prime of x is negative, and that happens on the interval from 1 to 2 and 5 to 6, we know f of x is decreasing. So always remember, your first derivative tells you about the slope of your function. The first derivative is the slope of your function. So it's going to tell you what your function is doing in terms of increasing and decreasing. Okay, question 3 and 4. It says find the open intervals on which f of x equals x squared minus 9 to the 2/3 power is increasing or decreasing. Okay, so this function, when we take its derivative, we will get 2 over 3 x squared minus 9 to the negative 1/3 times 2x by the chain rule. Simplifying this, we're going to have 4x in the numerator and 3 times the cube root of x squared minus 9 to the the cube root of x squared minus 9, or x squared minus 9 to the 1/3. We can also think about that denominator in factored form, x minus 3 and x plus 3. Okay. All right, notice the work that I'm showing, the algebraic process. It would be nice if your work kind of flowed in a similar way, an organized way, so that you can follow what you're doing. Okay, we want to know when the function is increasing and decreasing, so I need to look for when the derivative, I need to look for critical points. So f of x will equal 0 when 4x is equal to 0, or x is equal to 0. So there's a critical point. F prime of x will be undefined when the denominator is equal to 0. So that's going to happen when x minus 3 times x plus 3 is equal to 0. So 2 critical points there, positive and negative 3. Okay, let's look at our first derivative number line, just to organize our thoughts about when the derivative is positive and negative. So I'm going to put my 3 critical points on the number line. I know at those 3 critical points, the curve is undefined, 0, and undefined. All right, I'm going to think about what's happening on each of those intervals. Okay. And I like to think about this expression as a related polynomial. Okay, it's not a polynomial, but the related polynomial, meaning the polynomial that has all the same factors, 4x, 3x minus 3, x plus 3 to the 1/3. Okay, even that's not a polynomial because it's raised to the 1/3 power. But that 1/3 is not going to change the sign of things. The cube root of a number is either positive or negative depending on what the number is. So I'm actually going to ignore that cube root. Okay, and I'm just going to think about this as this related polynomial that's a cubic. Okay, and it's a positive cubic, which means it has to have this behavior. Starting low, going high, going low, going high. So I know that my first derivative number line is going to have negative values, positive values, negative values, and positive values. Okay, if you're unsure about that, what we can do is we can just test some numbers. Okay, so let's test negative 10. Negative 10 in the numerator, that will be negative. Negative 10 in the denominator will be a negative times a negative, that will be a positive. The cube root of a positive is a positive. Negative divided by a positive is a negative. Okay, so I just tested one of those intervals. But if you're unsure, and again, this question is no calculator, so I'm trying to use other strategies, test points in between. We could also test, let's test a positive 1. Okay, so the interval in here. So the numerator is going to be positive 1, positive 4, positive. The denominator is going to have a negative factor and a positive factor when x is 1. And so you're going to have positive divided by negative. So the answer there is also negative. Okay, so let me wrap up this question before time runs out on this video. So where's our function increasing and decreasing? All right, we're going to say f is increasing on negative 3 to 0 and 3 to infinity because f prime is greater than 0. We're going to say f is decreasing on the interval from negative infinity to negative 3 and 0 to 3 because f prime is less than 0. Okay, so remember, the number line is a nice visual organization of your thought process, but the only thing that the AP is going to read is this here, okay? Questions often ask you to justify your answer, okay? And so here is, the first part is your answer. F is increasing on this interval, okay? This second part, because the derivative is positive, is your justification. Okay, so recognize what in words you need to say in order to actually answer the question. Okay, I'm going to stop this video because I'm not going to be able to do question 4 in the time remaining, and I'll pick up in the next one.